For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. 1. Compute dx, where here x is defined to be the largest integer less than or equal to x. Solution. By the properties of the integral, we know that the above is equal to. Now, square root x takes the value 0 on 0, 1, and the value 1 on 1, 4, and the value 2 at x equals 4. Thus, we can rewrite the integral. 2. Let S be a square pyramid with base area r2 and height h. Using Cavalieri's theorem, determine the volume of the pyramid. Solution. Orient the square pyramid so that the base sits on the x minus y plane and the top vertex sits on the z-axis. Let as h0 denote the cross-sectional area of S intersection z equals h0, and note that this is a square that will be a function of r, h. To find the length of a side of the square at height h0, we consider r the line which contains the 2 points r, 0, and 0, h. One form of the equation for this line is y equals minus rh slash x plus h. Notice that here x is the side length of the square at height y. Thus, for y equals h0, we get x equals hr, h minus h0. Mathsassignmenthelp.com. That is, as h0 equals r2 slash h2, h minus h0. 2 for h0 is an element of 0h, and as h0 equals 0 otherwise. So, 3. Let f be an integrable function on 0, 1. Prove that f is integrable on 0, 1. Solution. Let is an element of 0. The Riemann condition implies there exists step func is an element of 1 times s, x, t, x, on 0, 1, such that s, x, less than or equal to f, x, less than or equal to t, x, and t, x, minus s, x, dx is an element of. Let p equals x0, x1, xn be a partition of 0, 1, such that s, x, t, x are both constant sk, tk on the kth open subintervals of p. Denote a subset of p such that a equals x is an element of 0, 1, sk, x greater than or equal to 0 or tk, x less than or equal to 0. Choose S1, x, such that S1, x equals min, s, x, t, x, for x is an element of a, and S1, x equals 0 for x is an element of p minus a. Choose T1, x equals max, s, x, t, x. Denote by S1, k the constant value taken by S1, x, on the kth subinterval. Define T1, k similarly. It is straightforward to check, using properties of the absolute value, that S1, x, less than or equal to f, x, less than or equal to T1, x, on 0, 1. Now consider any open subinterval, xk minus 1, xk. If sk greater than or equal to 0, then T1, k minus S1, k equals tk minus sk, and if tk less than or equal to 0, then T1, k minus S1, k equals minus sk minus tk equals tk minus sk. Finally, observe that if sk0 tk0, then T1, k minus S1, k equals max, tk, sk, tk plus sk equals tk minus sk. Thus, mathsassignmenthelp.com. It follows that f is integrable. 4. The well-ordering principle states that every non-empty subset of the natural numbers has a least element. Prove the well-ordering principle implies the principle of mathematical induction. Hint: let S subset of P be a set such that 1 is an element of S, and if K is an element of S, then K plus 1 is an element of S. Consider T equals P minus S. Show that T equals empty set. Solution: let S subset of P such that 1 is an element of S, and if K is an element of S, then K plus 1 is an element of S. We wish to show S equals P. Suppose not. Then there exists a set T equals P minus S, and by hypothesis T is non-empty. Moreover, as T subset of P, the well-ordering principle implies that T has a least element. Let M denote this least element. By Theorem 1, in course notes A, M greater than or equal to 1. Notice 1/T as 1 is an element of S, 1 is an element of P, and thus M greater than 1. As M is the least element of T, M minus 1/T. Claim: M is an element of P with M greater than 1 implies M minus 1 is an element of P. Proof of claim: suppose not. Then there exists an inductive set A such that M minus 1/A. Consider the set B equals A minus M. We wish to prove B is inductive. Since M equals 1, 1 is an element of B. Now suppose K is an element of B subset of A. As A is inductive, K plus 1 is an element of A. mathsassignmenthelp.com And thus K plus 1 is an element of B, or K plus 1 equals M. In the first case, B is inductive. The second case implies M minus 1 equals K is an element of B subset of A. This contradicts the construction of A. Thus, if M minus 1/P, then there exists an inductive set B such that M is an element of B. This contradicts the assumption that M is an element of P. It follows that M minus 1 is an element of P. Now, back to the main proof. As M minus 1/T and M minus 1 is an element of P, it follows that M minus 1 is an element of S. But by the properties of S, M minus 1 plus 1 equals M is an element of S. This contradicts the fact that M is an element of T. It follows that T cannot have a least element. The well-ordering principle then implies that T equals empty set. That is S equals P. 5. Suppose limx P plus F, x equals limx P minus F, x equals A. Prove limx P F, x equals A. Solution: let epsilon 0. By hypothesis, there exists delta 1, delta 2 such that P less than x less than P plus delta 1 implies F, x, minus A, epsilon, and P minus delta 2 x less than P implies F, x, minus A, epsilon. Let delta equals min, delta 1, delta 2. Then 0, x minus P delta implies F, x, minus A, epsilon. mathsassignmenthelp.com